Welcome back, everybody. Already in this chapter, we've talked about reflections and we've talked about translations. Those are two types of transformations. Now, the last type of transformation, that is a congruence transformation, is called a rotation. Rotation is like a turn or a spin. Each point has to rotate the same angle and be the same distance from the center of rotation. You want to assume that you're usually rotating counterclockwise unless it's stated otherwise. Alright, so we have some rules for the rotations in the coordinate plane. These are very important. I would suggest making some note cards for these to go ahead and start studying them. Or you can view my Quizlet online. So for the 90-degree rotation, remember this is for counterclockwise, you can multiply the y value by -1, then switch the x and y value. So if you have the point x comma y, you'll multiply the y value by -1 first, so it will become -y. Then you switch x and y, so it's -y comma x. For 180, you multiply both the x and the y values by -1, so x comma y becomes -x comma -y. And then 270, you multiply the x value by -1, then switch x and y. I have also a video to show you an explanation to help you understand why are these the way that they are. I can post that under the resources for this topic. Alright, let's do some examples together. So for this first example, I have already graphed triangle PQR. Remember, it's important that I connect the points and label each point on the graph. And it says to rotate it around the origin. All of these rules that I just gave you and all the rotations that we complete on coordinate planes are going to rotate around the origin. So what that means is the origin is our center of rotation that we are spinning around. Now, since it's a 90-degree rotation, I'll use the rule -y comma x. Remember, that means multiply the y value by -1, then switch the x and the y. So, for example, for the image of P, the first step is multiply the y value by -1. 1 times -1 is -1. After I do that, I have to switch x and y. So the image of P is going to be -1 comma 1. Similarly for Q, the first step is to multiply the y value by -1. +5 times -1 is -5. Then I have to switch x and y. So I get -5 comma 4 for the image of Q. Finally, for point R, I multiply the y by -1, so I get -1. Then switch x and y, so I get -1 comma 5. So you can plot those 3 points. You see I've already done that in pink as shown. Let's do another example together. So this says we're trying to rotate parallelogram FGHJ. Just as a note, I changed J to be 0, -3 to make sure it was a parallelogram. And we want to rotate it 180 degrees clockwise. Now, what are we going to do? Because our rules are for counterclockwise. However, 180 clockwise is going to be the same image as rotating 180 degrees counterclockwise. You could probably find the same rules for 90 degrees clockwise or 270 degrees clockwise, similar. And those are important to know as well. So for example, if you are starting at this center of rotation and here's point A, when we rotate 90 degrees clockwise to find the image of A, it's the same as rotating 270 counterclockwise. So see if you can come up with what would we do if it says to rotate 270 clockwise. What do you think we should do? If you said rotate 90 counterclockwise, you'd be correct. Okay, so we know that we're rotating 180 clockwise. So we'll use the rule -x comma -y. What this means is we take every x value times -1 and every y value multiplied by -1. So for the image of f, we first take x times -1, gives us -2, and -1 times 1 is -1. Next, for g, we take the x and the y both multiplied by -1, gives us -8, -1. H, we have the x value 6 times -1 is -6, and we haven't seen a negative value yet. Be careful here. Some people think that since it's already a negative in front of the y value, we just leave it -3. However, think about it. -3 times -1 gives us +3. So it's kind of like we're switching the sign for every single point, x and y. Finally, for j, make sure you remember 0 times any number is 0. So here are our points for the image. You can plot them on the graph as shown to the left. Alright, I want you to try these practice problems below. I didn't give you a graph because I think we know how to graph by now. We've practiced tons of graphing. But you can just write down the points for the rotations on the lines provided and write down the answer for the image. Here are the correct answers for those. And the last thing we're going to do today is talk about this reflection question. It says, if you start with a figure in quadrant 1 and you rotate it counterclockwise 90 degrees, what quadrant will the image be in? What about if you rotate it 180 degrees counterclockwise, 270 degrees, or 360 degrees? Remember, it's important for you to know the quadrants. Quadrant 1 is in the top right corner. Quadrant 2 is the top left. Quadrant 3 is the bottom left. And quadrant 4 is the bottom right. Based on the quadrants and our rotations, what we know about that, tell me, can you answer this question? Where will this figure end if we're starting in quadrant 1? Go ahead and answer that. Tomorrow we are going to talk about some compositions of reflections, rotations, and translations. We'll start with glide reflections and then talk about other compositions after that. So we're basically going to put together everything we've learned so far and combine it into multiple transformations all in one figure. I'm sure you'll understand those. We've done them a little bit with the transformation golf. You've done multiple transformations in a row. So we'll talk about that more tomorrow. I look forward to seeing you then. Bye.